Hello, hello. Welcome to another VTE segment. In this VTE segment, we're going to discuss one of the most popular topics in cloud, autoscaling. We'll discuss how this applies to FortiGate, how the FortiOS operating system manages autoscaling natively, and how it really solves for a key concern in cloud infrastructure. That is, how to cost optimize that infrastructure. At the end, we will go through a typical case of deploying autoscaling, where our example will be deployed on AWS. An important thing to note, and I'll mention this several times, is that the demo example applies rather consistently across the various cloud platforms. The first thing we should address is to scale up or to scale out. When does one apply versus the other? If you ask cloud providers or some of our competitors who don't scale up so well, they would say scale out is always the obvious choice. In reality, it depends. It depends on the use case. Are you terminating IPsec, which doesn't play well with autoscaling or active-active environments? For example, think about the different sessions over UDP 500 or 4500 for handling NAT as an example. Or if a session has to rekey and the new FortiGate doesn't have a record of the SPI for the VPN session. Or maybe a single IPsec service is maxed on a single appliance. How do you scale a single IPsec session tunnel to a second cluster member? These could present service problems in a scaled-out environment. Also, if you have a lumpy distribution of workloads with little variability in demand, that is no seasonal nature that would drive up the consumption periodically, or maybe something like a follow-the-sun impact, then scaling up against a standard baseline would be a better option. On the contrary, if one has great variability in demand, like a streaming video service, for example, that's consumed mostly at night, something like Netflix, or there's an expectation of growth in the not-too-distant future, or there's no IPsec use case, then horizontal scaling makes a lot of sense. So which is more cost-effective? That really depends also. With horizontal scaling, one can use smaller instances. If the baseline of persistent workloads is of a low volume or bandwidth, then this can be far more cost-effective. However, if there's a fixed baseline of bandwidth or possibly more than 2 virtual NICs attached to your instances, then vertical scaling can be maximized with CPU optimization and network acceleration on a fixed instance count. And lastly, keep in mind that autoscaling comes with some complexity in the infrastructure. There are more objects and services involved to run the autoscaling, any of which being impacted by an outage or configuration error could cause problems. With that explained, let's look at how FortiGate supports autoscaling. Again, our example here is AWS, but this could be any cloud that would look very similar. You'll notice some things here. You'll notice that there are 2 linked clusters, the BYOL and the pay-as-you-go cluster. Unlike what you typically see in competitive solutions where pay-go is supported for autoscaling, Fortinet provides hybrid licensing support. This is really, really important. This allows a persistent baseline to be deployed on BYOL, and any scaling can potentially be set up against the pay-as-you-go for usage-based charging. In this way, all usage is delivered at the lowest possible cost. The customer is only paying for what they use. If the baseline changes, the BYOL pool can be resized, which I'll get to in a moment. Being a hybrid license deployment also allows rescaling, the ability to support scale up or scale out. Need to scale up the baseline? Simply change the instance type supported for the BYOL instances, or add another instance to the BYOL pool. It's pretty simple. Solution delivery is also simplified. All of the components for autoscale are delivered as Fortinet supported templates. These are available through links on docs.fortinet.com or GitHub, and I'll provide those links a little later. Fortinet has multiple templates for autoscale, both as Node.js or Python, and they're provided as Terraform or in native cloud templates, such as CloudFormation, ARM, or Deployment Manager. As mentioned, this model you see here is pretty consistent, again, across all clouds. There are variables that are supported, such as the ability to attach, say, to the AWS Transit Gateway, which keys on the last point. Autoscaling with Fortinet is compatible with services such as Azure Virtual WAN and Transit Gateway on AWS. With Transit Gateway as an example, the autoscale cluster automatically manages VPN connections for ECMP attachment to the Transit Gateway. Let's look at this in more detail on the actual solution and the components involved. First, you see that we have a scaling cluster. There are 2 clusters, actually. These are your BYOL and your pay-as-you-go instance clusters. And there's our notification service. So when new instances are added to the cluster pools, a notification goes out that goes to a serverless function to handle a lifecycle process, and that lifecycle process allows traffic to be sent to the new instances. There's a database object, and here in AWS, it's the DynamoDB. And that database is a table that tracks things such as licensing allocation, which role the different cluster members are serving, DNS records for API gateway, and so forth. There's also storage. Now, for other auto-scaling solutions from competitors, storage is used to track the configuration files of the autoscale members. The FortiGates don't use storage in this way. The storage bucket is used for initial configuration of the master and a baseline configuration of any slaves that come online before they're synchronized. It's also used for licensing. All of the licensing is pooled in an S3 storage bucket, and those licenses are recycled as instances are brought online and retired. There's also a logging function. Autoscaling requires logging to support CPU utilization notification for when a cluster becomes saturated and needs to scale out. Now, if we look on the FortiGate, we can see a glimpse of how FortiOS supports autoscaling natively, which is something, again, that's not typically provided by others. FortiGates actually are aware of their role in the cluster, and they're aware that they're running in the cloud environment. Instead of getting a static configuration from a storage account, which can go stale very quickly, the slave devices, again, they sync with the master to get their configuration. They also get their API gateway URL from the master in order to check in with the serverless lifecycle management function to announce that they are ready to receive traffic and are in sync. The screenshot here demonstrates where one device, the master, is the BYOL, and the slave in this example is the pay-as-you-go. I've provided some additional resources for you to learn more and to start using the service yourself. It is really easy to start deploying, and you can do so from our official GitHub repo at github.com/Fortinet. There are additional APIs about which you can learn in demos for deploying on cloud located at fndn.fortinet.net and step-by-step guides on docs.fortinet.com/VM for the various cloud infrastructure implementations. So next, let's go into a quick demonstration of what this looks like in deployment and some of the things that you will want to take note of when your autoscale cluster is deployed. And then finally, we'll push some traffic through the FortiGate cluster so you can watch this scale out. So let's start from the top. We've navigated to the github.com/Fortinet FortiGate-autoscale-AWS releases directory. One of the things you'll notice is we've started to iterate on the version number for these various templates and packages that we make available. So what you're going to want to do is download the AWS-CloudFormation.zip file to a local directory. You also have the option to compile this from the source code, make modifications if you would so like, uploading it to S3. So you'll create an S3 bucket. In this case, I've just named it FortiGate Autoscale. I've loaded this deployment package, which is the package from the GitHub site, and it'll be organized into these folders. Now, there's a couple things that you'll have to keep in mind. The templates folder has the templates for autoscaling for different use cases. You can deploy with a transit gateway, and you can deploy without a transit gateway, and you can deploy with an existing VPC or a new PC. These various constituent templates are part of an overall stack, and many of them get deployed together. But if we come back up to our parent folder, we also have assets. Now, there's a couple of folders we're going to have to create in our assets directory. We'll want to create a license file folder, and within that license file folder, we want to name that FortiGate. And this is where we store our licenses. And these license files are going to be used and picked up by the automation to start licensing the BYOL devices. So now that we have these and we have them in the appropriate directories, we can go ahead and get started. One more thing I'll point out before we get started is this config set. In the config set folder, we'll have various constituent items of our FortiGate configuration that get bootstrapped when our instances start. This is the baseline configuration to get the FortiGates running. Now keep in mind, again, this is not the final configuration. The slave devices will get their complete configuration from the master, which can be configured at any time while it's running. So if we look at the base configuration file, we have DNS settings, we have support for the autoscale configuration. So we talked about being autoscale aware. Here's where the config system autoscale is configured, the role for the master. One of the things that will happen when the slaves come online is that their role will be set to slave if there's an existing master in the autoscale cluster, and that is going to be tracked in the database and with the serverless function. And then they'll get their callback URLs and all of their other configurations from the master FortiGate. Now, there's some other files in the config set folder. Here's another example where changes may be made at the user discretion. You may have different BGP configurations that you'll want to configure, as well as different tunnel settings. So in our case, we're going to deploy the autoscale solution without the transit gateway. We're going to actually deploy this with a front-end load balancer. So this might be an example where you have ingress traffic into your cloud environment, and this will deploy a load balancer on the front end of the FortiGates. The FortiGates will be a managed cluster off that FortiGate, looking for specific traffic to be distributed to them. They forward traffic to back-end protected resources. So now we'll navigate to CloudFormation, and we'll create stack. We want to deploy with new standard resources in this sample scenario. Next, we'll enter parameter details to deploying autoscaling on AWS. All of the parameters are fully explained in the docs.fortinet.com page for deploying autoscaling on AWS. To speed this along, I've already filled out the parameters, and so we'll just go through those really quickly. The stack name is the name that we're going to give this stack that's being deployed. So if you deploy multiple stacks, you have a name for it. The resource tag configuration is a prefix that's going to be applied to all the resources that are deployed. Network availability zones, you'll have to select at least 2 availability zones. This solution deploys for high availability ELB endpoints into multiple availability zones over which it deploys the FortiGates. The VPC CIDR is filled out with a default. You can change this to fit your VPC needs or use an existing VPC if you so choose. This is just a VPC CIDR standard /16 block with /24 ranges deployed in 2 availability zones. We have subnet 1, which is a public subnet. We have subnet 2, which is also a public subnet in our second availability zone. And then we have the protected subnets, the 2 backend subnets in the respective availability zones. The default instance type here is selected as X large, but if you have a baseline that is lower and does not need as much bandwidth, then you can change this to a smaller instance type or a larger one. We're going to deploy this currently on 6.2.3. We've entered a secret such that the FortiGates can communicate securely between them as they go through the configuration process. The admin port we're changing because we'll be forwarding potentially HTTPS traffic, and we will not want a conflict there. We're going to leave it open to management in our demo to all ranges, but I would suggest restricting that. The key name pair is just a key that you have to apply in your zone. Now, let's spend a minute going over the autoscale group configuration. We have 2 clusters. We have the BYOL and we have the on-demand. Our BYOL is going to have a baseline of 2 instances, always have 2 instances as a minimum, and will be no greater than 2 instances. Our license pool has more than 2 licenses. If I wanted to rescale this and change the baseline in runtime, I could do that in a 3rd instance or 4th and so forth would spawn, and I would be horizontally scaling my baseline. We're going to leave our desired capacity for on-demand at 0 currently. So we will spawn in our demo a new Pego instance, but we're initially going to start off with 0. So initially this will look like a statically scaled cluster. We're configuring our scale out threshold to be a lower number. So we're going to do 30% so we can easily see that auto scale event after I generate some traffic. The scale in threshold is 15%, so we'll see that scale in very quickly as well. There's some timers here that you can leave at the default. These timers are set to handle the primary or the master election process, and there's a timeout value there to manage the lifecycle hook. There's a certain amount of time, in this case 600 seconds, to get a license. This health check grace period is important because the auto-scaling service is going to check to make sure that the instance is healthy and that it's completed its lifecycle hooks and that it is online and ready to receive traffic. The cooldown period will allow the auto-scaling environment to stabilize before additional instances are spun up so that the process is controlled and it doesn't run away. Failover configuration management. So this is the heartbeat interval between the FortiGates and the autoscale handler. If an instance doesn't respond for 30 seconds at 3 intervals, then that instance will be deemed unhealthy and will be replaced. In our case, we're deploying a load balancer. You can deploy this as a network load balancer, an application load balancer on the front end. We're changing to port 8080 because in our test case, pushing traffic through port 8080, we're not doing an internal ELB. In this case, this would be an ELB to which the FortiGates would build a VIP to forward traffic to an internal load balancer. We're not using any custom configurations or custom assets or custom directories, so this can be left blank. This can be left blank. If you would like to change or modify your directories or the assets that you deploy, instructions on how to do so are in the docs.fortinet.com instructions. And then we're providing the bucket name. We looked at our bucket before, our autoscaling directory, or S3 bucket in this case, and then the folder that will have our assets and license files. You can add some tags. We're going to skip all of this, and you can review these things. Here we're going to let our stack build. It'll take just a little bit of time, but we should be able to see our progress. We'll refresh this, and we should see this coming to a complete for all of these items. Now we can validate what our CloudFormation template deployed. So I'll filter for my VPC that was created with our prefix, FortiGate Autoscale Group, or ASG. We can see that there were 2 subnets deployed. Each of these are in our respective availability zones. We see here A, B, A, and B. We can see the autoscale instances that were deployed. You'll see this FortiTester here. This is the instance we're going to use to generate traffic to our autoscale cluster. They're all running in the same VPC. Some other things that we can validate. Our FortiGates are deployed with public IP addresses so that we can log into those. And these, again, are our BYOL instances. We can navigate to the Dynamo database to see how our tables were deployed, and we can look at some of the tracking information here. Our database tables immediately show us some things that are important. We see here the licenses that were loaded to our S3 storage, and we have 3 of those licenses that I had in that repository. We can see some detail about how licenses have been used. Right now, there are 2 licenses in use. If you go back and look here, as we pointed out, we have 2 BYOL members. We can also see which autoscale member is elected as the master. In this case, it's the device with IP ending in 2.36. And here are some more configuration details about the objects that were deployed and the defaults that were used. And we can see everything about our autoscale cluster in great detail. All of the values that were provided by the template to deploy our autoscale. Next, let's look at the load balancer. In this case, we've got 2 load balancers. For our tests, we're only using the front-end load balancer. And this load balancer has a listener configured specifically for port 8080. Now, our template also deployed 443, but I went back and added port 8080 for our FortiTester testing. We can look at our target groups. Our target groups are responsible for forwarding traffic on particular ports. One of the things that we've configured here is, while our forwarding traffic is on port 8080, our health checks are actually using the FMFG protocol port 541. This just validates the availability of the FortiGates on that port as a TCP connection. If the FortiGate responds on this port, completes the TCP handshake, then that instance is deemed healthy. This is an easy way to implement a health check that's not using the same port as your target group primary port. And the reason that that's important is because if you're not able to get a response on this port, which the FortiGate doesn't automatically respond to, the instances, while not receiving traffic or not processing traffic to a backend service that does respond on this port, these instances would be deemed unhealthy. And lastly, let's look at our autoscaling groups. Remember, there are 2 autoscaling groups. We can see here our BYOL autoscaling group that works cooperatively with our pay-as-you-go group. The BYOL group has 2 instances. This is our baseline with our desired capacity to maintain 2 devices, always at a minimum of 2 devices. If we look at that detail a little bit more, we can see that this is configurable. If at any time in the future I wanted to edit these desired amounts, I wanted to horizontally or manually scale out my BYOL, I can easily do that by adding or taking away instances. We can also see activity. If they have scaled at any point in time, then logs would show there. And under instance management, we can see the state of our BYOL autoscaling members. Here I have my instance IDs. We want them to be in service. That's our target state. This may be, if this says pending or some other state, that means it's not ready to receive traffic and something may have to be resolved with the deployment. There are two lifecycle hooks that manage this, the abandoned lifecycle hook and the instance terminating lifecycle hook. And we see the status of these from the autoscale perspective, again, not from the BYOL. Finally, we see that this health status from the autoscaling perspective is healthy. This isn't the same as the health status from the load balancer, which just seeks to see if the instance is able to receive traffic for forwarding. With this review completed, let's start pushing traffic through our autoscaling group. Now look at our FortiGates. I'm going to log into my two BYOL FortiGates. The first instance I'm logging into here, I've already named the host name BYOL-1, so I know this was the first of the two. It happens to be the master in this case, and it's been configured as such. I have a second FortiGate, and this one's configured as slave. If I make any changes to policy or objects, they will end up syncing from the primary FortiGate to all subsequent FortiGates. So here we see the same policy. Navigating back to our dashboards, I'm going to start to push traffic through these FortiGates so that we can see the CPU utilization ramp up and we see the autoscaling event occur. Okay, I'm logging into FortiTester. If you haven't used FortiTester before, it's a fantastic tool for synthesizing threats and generating traffic. For demonstration purposes, we're going to run a CPS test, and this test will push as much traffic and as many connections as possible through the FortiGate autoscaling cluster. Now, traffic is going to be destined for the load balancer IP address. That load balancer will forward traffic to the FortiGates, distributing sessions across availability zones to both FortiGates. And those FortiGates will process a VIP, and that VIP will push it back to a back-end responder to respond to the port 8080 traffic. What we want to see here is that we have successful TCP handshakes and completed sessions. So we are seeing those three-way handshakes complete. We don't have any failures, so that's looking good. Let's go back to our FortiGates. Now what we can see is traffic being pushed up. On this particular FortiGate, we're above 70%. So what we see here is our session count ramping up. We're at 18,000 sessions and about 80% CPU utilization. At this point, we should start to see the lifecycle process take over. Remember, there's a hold down period. So that hold down period has to expire, after which point a new FortiGate instance will appear. So as you can see here, we have a new FortiGate being spun up automatically as a PAYGO instance. It's initializing right now. And we want to make sure that instance is being added. Now you see here it's pending. So this device is coming online, and as it boots up, it's going to get its initial configuration. That initial configuration will tell it it's in an autoscaling service. It will then communicate to the master FortiGate to get its appropriate status. So if there is a master FortiGate, that master FortiGate will tell it that its role is a slave role. It'll give it the callback URL for the existing API gateway. The slave member will also sync the configuration directly from the master. Once that's complete, it will tell the automation function, in Lambda in this case, that it's ready to receive traffic. So we should see this lifecycle status go from pending to in service. While we're waiting for that process to complete, we can come back to our new PAYGO instance and grab the IP address off that device. Now that our new FortiGate has spawned and is in sync, by the way, we can check this right here. In the database, we see that this is our 1.109 FortiGate that just came up as part of our PAYGO. We see that as part of the PAYGO autoscaling group, and now we see that device is in sync. And we can now log into that device. So it should have synced the admin password and all of the other configuration. And it looks like it did. So we can specify a host name. I don't want to because these are ephemeral. But now we can see that this device is coming up. We can see the CPU allocations. We see there's no actual license attached to this because it is a pay-as-you-go instance, and its role is slave. So everything looks like it was configured correctly. We can check our network policy just to validate that. We have the same network policy with our VIP that was created on the master. So everything did sync. So now that this is autoscaled And we can see it's also taking some sessions here, so that's fantastic. Once it came online, traffic started to be directed to it from the load balancer. The last thing we'll want to do is see this thing scale in. So we'll see this device go away after the cooldown period. So what I'm going to do is I'm going to stop my FortiTester. So in terminating that, we're going to look at our instances. And what we'll see is this instance, after 300 seconds, will go into a terminating state. Finally, we see the instance has terminated, the cluster scaled back into its original size, and we've completed a whole cycle of autoscaling. I hope you've enjoyed this VTE segment. If you need more information on autoscaling or anything else at Fortinet, please visit the resources that we provided. And this concludes this VTE segment. Thank you for watching.